I'm Sven. I have a background in electrochemistry, nanotechnology, and sensing, and have been deeply involved in several TTP biosensing projects of various scales at different points in their journey. My expertise positions me nicely at the interface between chemistry and physics, with some materials science and precision metrology thrown in for good measure. In addition to leading projects, this positions me well to characterize biosensors of all shapes and sizes, and to help our clients with their testing requirements, both in the early stages of developing a new sensor, but also ensuring repeatability when scaling to manufacture. Aside from the classic challenge of balancing timelines, effort, and rigor to match individual client priorities, designing the systems and automation required for efficient sensor testing also requires knowledge of the regulatory requirements for device submission, as well as sources of potential artifacts and how to overcome them, and the many confounding factors one may otherwise encounter. Ensuring tests are well documented, reproducible, and to a high quality is key for submission. Similarly, understanding the variability in the data and if there are any artifacts in the data, whether they come from the testing system and methodology or the sensor under test, is incredibly useful for both submission and device development. Employing a good balance of computational simulation and practical know-how to probe transport, kinetic, thermodynamic, and even aging properties of sensors enables rapid design iteration, and understanding how to then translate this into low and then high-volume testing can be critical. Being able to rapidly spin up a test methodology collaboratively with a client, then test sensors and provide immediate analysis and insight on the results, which then feed back into the development program, is incredibly powerful. Additionally, having extensive experience in fluid dynamics, microfluidics, and sample handling allows us to perform complicated test procedures with multiple analytes in a reasonably high throughput, providing insight at a statistically useful level. A client of ours had built an in vitro test system to measure the response of their sensors over several weeks, but were seeing different artifacts in their data and weren't sure if it were coming from their sensors or their testing setup. TTP were able to help our client better understand the artifacts they were seeing and their sensor behavior, and then design and build a bespoke test system that ensured that any recorded characteristics were representative of the sensor and not the test. This meant that design changes could be made to the sensor to refine it for its application, driven by the testing work. The client was able to rapidly iterate a sensor design with a high degree of confidence that the changes that were being made were detectable and representative in the test data that was gathered, and also that this was going to be valuable in building evidence for a later regulatory submission.